Our universe. Literally everything that you can see and hear right now. You, me, beyond the Earth, beyond the sun, and beyond the galaxy. Like anything has to, our universe started at one tiny moment in time. Only our universe had a rather violent start, simply called the Big Bang. But how do we know about this incredible phenomenon? The greatest explosion ever to occur in known history. Today we look back on the long path that it took to get to this stage in our understanding of our universe and its beginnings. Nobody knows how or why the Big Bang happened. All we know is that it did happen. The first person to come up with the theory of the Big Bang was Edwin Hubble, who with a little help from Albert Einstein found that the universe was expanding constantly. After coming up with a theory of relativity in 1915, Einstein applied this theory to different places in the universe and found that if this theory was correct, the universe would be either expanding or contracting at all times. Then Edwin Hubble came along in 1929 and measured the velocities of different galaxies around us, expecting that some would be coming closer to the Earth and others would be going away. And instead, he found that everything in the universe was moving away from one another, being propelled into space. And in this way, he realized that the universe must have started with some great explosion. The Big Bang. Hubble's discoveries sent shockwaves through the science world. It finally answered the question that people had been asking for centuries. How did this all get here? But like any great discovery, it also raised many questions. The biggest being, how did the Big Bang happen? This is a question that had scientists stumped for decades, but then we made a breakthrough. Penzias and Wilson were just two scientists, looking at stars, when they noticed something strange, something that shouldn't have been there. During the time that Penzias and Wilson made their discovery, many people still didn't think that the Big Bang theory was logical, or that it could have happened, and instead turned to the steady-state theory, which stated that the universe was simply always as it was, and would stay pretty much the same for eternity. What Penzias and Wilson saw was a disturbance in the universe that was different from the rest of the space around it. What they were looking at was the microwave background radiation from the Big Bang. However, like always, even more questions were raised. Something was strange about Penzias and Wilson's discovery. The intensity of the microwave background radiation was too evenly distributed, varying only 1 part in 100,000 from the coolest point to the hottest in any direction. A normal explosion has some hot spots and some relatively cooler. Not everything gets so evenly distributed. There is just too much random chance in any normal explosion to expect such an even distribution of the energy. The even distribution of the energy stumped scientists because the energy had not made it from one side of the universe all the way to the other side, even if it had been traveling at the speed of light. Einstein had already proven that nothing can travel faster than light, so how could the Big Bang energy diffuse? Then around 1979, Alan Guth came up with a theory of inflation. In other words, that the universe had expanded so quickly that for a short amount of time, somewhere between 3 and 4 trillionths of a trillionth of a second, the universe was expanding at a rate faster than the speed of light. This is possible because just after the Big Bang, when the universe was not even close to a nanosecond old, light particles, or protons, had not even started to form yet. And as the universe slowed down slightly, when it was around 0.0000001 seconds old, that's when protons began to form, and light started to exist, as well as its speed cap. Though matter and energy were still too dense for light to be able to radiate, this theory could also explain why we can't see farther into the past with telescopes. You all probably recognize these pictures of exploding blues, greens, oranges, and reds. However, you may not know that these pictures are not actually from the Big Bang. The distance that light travels in a year is called a light year. So if you look at something that's 1 light year away, you're really seeing what it looked like a year ago. In this way, if you look at something, say, 12 billion light years away, you're seeing what it looked like 12 billion years ago. So when scientists look far away, they can see what the universe looks like in its early stages. However, they can only see up to about 380,000 years after the Big Bang occurred. This is another reason that Guth's theory of inflation is so intriguing and important. Because not only does it state that at one point the universe was going faster than light, it also states that electrons being released and flying freely scatter light, and therefore the earliest visible universe is around 380,000 years old, rather than right up to the moment of his birth. The symmetry of the background radiation was discovered years ago. Then scientists coupled Einstein's theory of relativity with Guth's theory of inflation and predicted that the radiation would have swirls in its polarization. And that's what Kovac and his team just discovered. On March 17, 2014, a team of scientists located in Antarctica announced a discovery that provides backup on the theories of Hubble, Einstein, and Guth. The spirals in the radiation's polarization were found. The same swirls that Guth, Hubble, and Einstein knew would be there. But so far, we've only been looking at the scientific discoveries down this path. Now we look at new areas. The Big Bang Theory and the discoveries leading up to it did not only have scientific value, but political value as well. In fact, the space race and landing a man on the moon would never have happened if not for the discoveries made by the same scientists who discovered the Big Bang. Most people probably know that Sputnik was the thing that pretty much started the space race. On October 4th, 1957 at 7:28 p.m., Sputnik launched. The first satellite was now in the air, and about a year later was followed by Sputnik 2, which carried the first passenger into space. Laika, also known as Mutnik, was the first Earthling to travel into space. And at this point, good old America wanted some of the action as well, and so sent the first chimpanzee into space on January 31st, 1961. This was the first primate in space, and 4 months later, Russia launched the second primate in space, astronaut as well as human, Yuri Gagarin, the first human ever to travel beyond the Earth. Only 1 month later, however, American Alan Shepard does the same, the second human and first American in space. Later that same year, NASA responds to President Kennedy's famous challenge to land a man on the moon with the Apollo program. As America prepares this program, Russia sends the first woman to space and has the first spacewalk. Then, tragedy with the first-generation Apollo. Gus Grissom, the first man to go into space twice, Ed Wyatt, and Roger Chaffee all die on January 27, 1967, while inside their training capsule. A faulty wire had caused a spark, setting the entire capsule alight. Even as NASA agent worked frantically to free the men, it took 5 minutes to get the door open. By then it was too late. This tragedy set the Apollo program back by nearly a year. While the Americans worked to get back on track, Russia was also working towards a lunar landing, but it was set back by rocket failures.
2, 1.
And at last, on July 20th, 1969, Neil Armstrong takes his famous first steps on the moon's surface. America is the first country on the moon. Then July 21st, 1969, the very next day, the Russians' lunar probe crash lands on the moon. The race, and the glory, is won by the Americans. And no Russian has walked on the moon. $24 billion after the Apollo program started, America can enjoy its moon dance. As for the economic ramifications, NASA created thousands upon thousands of jobs for scientists, engineers, and nerds of all kinds. This helped the job market and the economy, and while it continues to create jobs today, there are other companies doing the same. Now there's a private company called SpaceX getting in on the space exploration action. Created by Elon Musk, the same man who created the Tesla Motor Company, SpaceX sends cargo ships into space for NASA and does other jobs like this that involve space. It is the first private space company, and it is creating more jobs today. And the social implications. The space race had a lot to do with the Cold War. This war was more like distrust and competition between the communist world, especially Russia, and the free world, especially the USA. Many people were afraid that Russia was going to bomb America, or the other way around, and it would start a nuclear war. There are so many great things that the science world has done, and it has helped our country and the world, not only to understand how things work or how we got here, but to utilize our world while taking care of it. People like this help to change the course of history and the world as we know it, because so much of what we know about the world is thanks to them.